Dear students, in this lecture we will learn about elementary row operations. What are elementary row operations? Elementary row operations will be abbreviated as ERO, elementary row operation. The first thing is interchanging any two rows represented by this notation. Ri will be interchanged with Rj. So that is the first elementary row operation, one of the elementary row operations that we can interchange any two rows. Interchange any row with another row is allowed. The second one is multiplying any row by a non-zero constant. We will be in position to multiply any row with a constant number, any constant number which is not zero. So multiplying a row by a non-zero constant number is allowed, an elementary row operation. And the last one is adding or subtracting any two rows. For example, if there is a need of adding two rows or subtracting two rows, so this will be allowed in the sense of elementary row operation. So these three are called elementary row operations: interchanging rows, multiply row by a constant number, and adding and subtracting any two rows. These three are called elementary row operations. Number 4, if you obtain a matrix B from a matrix A by elementary row operation, then we will say that A is row equivalent to matrix B, and then we write this symbol that A is row equivalent to B. Now here is an example. For example, a matrix A is given to you and you are asked to perform the following operations: multiply row 1 by 2, interchange R1 and R3, and subtract 3 times row 3 from 2 times row 2. So let us see how could we perform these operations. The first one is, this is A, we need to find 2 times R1, so we will multiply row 1 by 2. This row 1 is multiplied by 2. See, 2 times 1, 2 times 2, 2 times 3, and this is actually 2 row 1. Now multiplying, 2 ones are 2, 2 twos are 4, 2 threes are 6. So that is the obtained matrix from A. Now this matrix is obtained from A by elementary row operation, so we put here this notation: row equivalent to this matrix. This A is row equivalent to this matrix. So that is 2R1. Secondly, if you want to perform this operation, if you want to interchange R1 and R2, then that is matrix A, interchange R1 and R2. So you see, we have interchanged this row with R1, write this row in the first one, in the first row in the second row. So this matrix is obtained from A matrix by elementary row operation. So that's why we put here this symbol that this matrix is row equivalent to matrix A. And number C, we need to find the difference of 2R2 and 3R3. So that is matrix A. This matrix A is row equivalent to this matrix by this operation. Now how could we perform this operation? This is discussed here. First of all, we need to multiply R2 by 2. This R2, 4, 5, 6 will be multiplied by 2. So 2 4s are 8, 2 5s are 10, 2 6s are 12. Just look at this: 2 R2, 8, 10 and 12. Now secondly, multiply R3 with 3. So this is R3, row 3. Multiply this whole row by 3. 3 sevens are 21, 3 8s are 24, 3 9s are 27, so 3 r 3 is 21, 24 and 27. And lastly we need to subtract these two. So subtracting 8 minus 2r2 minus 3r3 implies 8 minus 21, 10 minus 24, 12 minus 27, and this is the required result. 8 minus 21 is minus 13, 10 minus 24 is minus 14 and minus 15. We need to write these numbers, these elements, and row 2. Remember that the first row 2, we'll write these numbers in row 2. So just look at that. Minus that is actually minus 13 and minus 14 and minus 15. So correct these numbers: minus 13, minus 14 and minus 15. So that is 2r2 minus 3r3. Now here what is the pivot element of a row? Pivot element of a row. The pivot element of a row is the first non-zero element of a row. Look at the row and see what is the first non-zero element in that row. So the first non-zero element in that row is called the pivot element of that row. For example, just look at this matrix. And this matrix, that is row 1, this is row 2, and this is row 3. In row 1, the first non-zero element is 1. So this is the pivot of row 1. In the second row, the first non-zero element is 4. So the pivot element of row 2 is 4. And in row 3, the first non-zero element is 2. So the pivot of row 3 is 2. So that is the pivot of a row. Secondly, we need to solve the system of linear equations by Gauss elimination method. We have discussed that how could we solve the system by matrix inversion method, number 2 Cramer's rule, and now we need to solve the system of linear equation by Gauss elimination method. So in this method we will write the system in matrix form, and then we will convert the augmented matrix. What is augmented matrix? The combination of A and B, which is written in this form, A slash B or A dotted line B. This is called augmented matrix. So we will convert this augmented matrix to upper triangular matrix by using elementary row operation. What is upper triangular matrix? All elements below main diagonal are 0. For example, that is a matrix. This is the main diagonal of this matrix 1 4 2. Below this main diagonal all elements are 0. So we will say that this matrix is in upper triangular form. If above this main diagonal these elements are 0, then we say that this matrix is in lower triangular form. Anyways, so we will take the augmented matrix and will convert the augmented matrix to this form, that below this main diagonal all the elements are 0, and these elements will become 0 by using elementary row operation. And the last step is, whenever we convert the matrix to upper triangular matrix, then we will use back substitution to find the solution. What is the back substitution? That is, we will start from the last row. To find x3, x2 and x1. Now there are some notes. The first one is partial pivoting using Gauss elimination method. What is partial pivoting? So remember that we will rearrange rows with greatest pivot element and absolute. greatest pivot element in absolute. Absolute means if there is a negative sign with a number but that number is large, so we will ignore the negative sign and will deal that number as the pivot element of that row. So that is called the partial pivoting, that we will rearrange the rows with greatest pivot element n. So that is partial pivoting. And number second is complete pivoting. What is complete pivoting? Select the pivot row as the row having largest value wherever in that row. You will see that what is the largest element and the row, what is the largest coefficient and the row, so that will be considered as pivotal row. Anyways, we are interested here in partial pivoting. Partial pivoting, if you are asked to solve the system by partial pivoting, then what will be the steps? Number C, for our convenience we will make the pivot element 1. That is not necessary, but our convenience we will make the pivot element 1. What does it mean? This is the pivot of first row, so we will make this element 1. This is already 1, and that is the element, that is the pivot of row 2. So this element is the pivot of row 2, so we will make this element 1. How could we make this element 1? We will multiply this row by 1 by 4 to make this 1, and that is the pivot element of row 3. We will make this element 1. How could we make this element 1? We will multiply this whole row by 1 by 2 to make this element 1. So this is for our convenience. All these steps will be followed in Gauss